All right, let's continue with section 3-4, and hopefully we'll get through this. So we did three things. What was the first thing we did on 3-4? Distance, right, the distance between 2 points, and then we just finished what? The midpoint, okay, the halfway distance, right, between the 2 points. Now what we're going to do is talk about the slope of the line, all right? And given 2 points, you should be able to find the slope of a line. Well, the slope of a line is basically just like how much is it slanted and what direction is it slanted, all right? So when we talk about the slope, we talk about going up and down something. So like in real life, when you think of going up or down a slope, what do you think of when you think of go down a slope? Okay, going down a hill. Like when it's snowy out, what do you think of doing? Maybe you've done this, maybe you haven't done it. Okay, going skiing, yeah, okay, going skiing, right? You go down slopes when you go skiing, okay? You talked about a hill. I used to do a lot of hiking. Did I show you a hiking video yet? No? Okay, one day, maybe before a break or something like that, I'll show you one of my hiking videos. And I went up lots of slopes, went down lots of slopes, okay? I even had an app, and it actually shows you kind of how steep the next section was. And you look at it, and when you saw something like this on the app, you're like, oh no, that means I got to go up this crazy long hill. But then if you saw from point A to point B and it was like that, you're like, oh, I can deal with that. And then when you saw it like this, what do you think that meant? You were going what? Down. You were going down the hill, okay? So with all that said, slopes are pretty important. So going from left to right, okay, we read left to right. So going from left to right, which way are we going? Going up the hill, right? Okay, so the slope's going up. What do you think of, negative, positive, when you think of going up? Positive. So we call this a positive slope. So if it goes from left to right, now I don't know what the number is for this slope, okay? They didn't give me any actual points or anything, but I do know that it's going up from left to right, okay, in that direction. It's positive because it's going up. So obviously, what do you think that slope is? That would be negative. All right, again, from left to right, look, you're going down the hill. Everybody see that? Going down. So that would be a negative slope. Again, just by looking at it, there's a slope. What if you had a line going this way? What kind of slope does that have? It's got zero slope. Very good. Okay, this is zero slope. It's completely flat. All right, if it's completely flat, that's called zero slope. For instance, if you're going skiing, right, and you just stand there, nobody's pushing you, the wind's not blowing you or anything like that, okay? You got no rockets on your skis, you haven't pushed off, you're just standing there. How fast are you going if it's completely flat? Zero. You're going zero, aren't you? Okay, so that's a zero slope. What about this one? Has anybody in here actually gone skiing, snow skiing? Okay, they have these color-coded hills, don't they? They got like green, I forget, green's the easiest, I think, then blue's the next hardest, and then what? The black, right, the black diamonds, okay? When you go to the black diamonds, that's at the top of the mountain, and that's the hardest way down, okay? It's the most fun way. I love going to the black diamonds when I used to ski. I haven't skied in a long time. You don't do the black diamonds? No. It's pretty scary when you get up there and you look down and you're like, oh my word, I got to go down this thing. But, you know, they have those up there. Do they have any colors or any shapes that describe anything like this? No. There's no way. Do you think you'll ever go to a ski slope where it's perfectly vertical, where it's going down? It's just a drop, exactly. All right, so there's no way that you would do this. So does it even exist? If you go to a ski resort thing, does a slope like that even exist? No. Now there may be a sheer cliff, but they got fences and they got signs. They say don't go this way, right? Because that's not part of our ski slopes. So it does not exist. Okay, so we say we could say undefined, or a lot of times they'll say this. They'll say, this is no slope. That's different than zero slope. A lot of times people think, oh, zero and nothing is the same thing. I mean, I understand why people would say that, but zero is something. Zero is a number. I can add zero to something, can't I? I can multiply something by zero. I can subtract zero from something. Now, I can't divide by zero, but I can take zero and divide it by something else, all right? But zero is something. No slope means it doesn't exist. So this does not exist, and you're going to see that a little bit later. All right, I was not going to tell this story, but I'll tell it real quick. All right, you ready for my story? I tell this every year. I teach slope for the first time, so I might as well tell it again. So when I was in college, I was in a thing called ROTC, Reserve Officer Training Corps, I think is what it stood for. It's kind of like being in the Army, but you're not really in the Army, and then you do all these fun things, like we learn how to shoot guns and learn how to take apart the gun and clean it and put it back together and all this kind of thing. And then they would take us through the woods. I went on this one night thing where it was overnight, and it was in the woods, and we had our little, I don't even know, I'm not an Army guy or a military guy, but we had this little group of people, and we had to go out and search and try to find the other group. And we had guns. They didn't have real bullets in it. They had blanks in it. So you could shoot them and they would bang, bang, just like a regular gun, but nothing would come out of them. So we go around. We never did find the group we were looking for. And we never did get to shoot the guns, even though they were blanks. I was so disappointed. But so we did that. And then one time we took a trip out. I went to school in Virginia at Liberty University. It's in Central Virginia. We went out to VMI, which is called the Virginia Military Institute. And it's a college. But you go there, you want to be in the military and that kind of thing. So we took a trip, it's like on a Saturday, out to VMI, and these guys were doing rappelling. Do you know what rappelling is?
Is that where you go down a cliff?
Yeah, exactly. So it's like this. So, right, so here's like the ground, and then it goes straight down like this, all right? And then you got these ropes. A lot of now, if you go rappelling with somebody, they usually have all these harnesses, right? You step into, and they got these belts and all that kind of stuff. When we did it, they called it a Swiss seat, I think is what they called it. I mean, it's been 40 years since I've done this. So it was just a rope, just a long rope, and they showed how you'd put it around your legs, around your waist, and you do all this stuff, and you cinch it tight, and there you got your own little harness. You made it from just a straight rope. It was kind of cool. And then the whole rope went way out like that, and they started off on a little slope. So the little slope went about like that. So here I was, this is me, holding onto a rope, and there was a tree, boom, boom, there's the tree. I don't know, the rope was attached to a tree, and then you would let up on the rope, and then you'd kind of scooch down the hill. Who's that?
Selena Hamway.
Oh, yeah, she is.
Can you send to the office for a moment?
Okay.
Thank you.
All right. So, and you go backwards, right? You just kind of let out the rope a little bit. In fact, you took the rope and you put it behind your back like this. And so, when you let up like this, it would let slack out on the rope, and you just kind of scooch down the hill, right? At first, that was pretty easy. I mean, I could have walked down that hill if I wanted to, all right? But we practiced there. Then, guess what? We went to this place right here. So this is me. Does that look like me? All right. And then they had some pole here or something, and the rope was attached to the pole, and you had to go down this thing. And it was no slope. It was completely vertical. And down the bottom were all these boulders. There was land, but there was all these boulders down here at the bottom, right? And I was pretty far up. I can't remember how high, but it was pretty high. So the guy's like, and a bunch of people have done it. I was sitting there watching everybody else. Okay, that was cool. It was my turn. Really wasn't all that nervous, but I get there, and so I kind of scooch down there. Now, you're attached to the rope. It's pretty tight, so you're letting all your weight on this rope. And so you scooch back, and then you're eventually like this, right, holding on to the rope, and eventually you're like this, holding on to the rope, okay? So I'm completely perpendicular, right? So this is me. So I'm like this, right? And the guy's like, let out a little. At first I was like this. He said, let out a little more, because they want you perpendicular. They want you completely flat. And he keeps on saying, let out more, let out more. So what do? I'm like, this. And of course, guess what happens? I let out so much. What do you think happened? This is my head, and that's my feet. Boom, I didn't slip out of it, but my feet came up like this. So here I am. This is me, right? Boom, boom. Here's my arms. I'm hanging onto this rope, and I'm completely upside down. All these rocks down the bottom. I'm completely upside down, hanging on this rope. And the guy in charge, he was an Army Ranger. This is VMI. They train all these Rangers who's like, top military guys. And he's like, don't move. He starts yelling, like really, like, and I was kind of nervous. I was completely upside down, right, hanging onto one rope. But I guess I was nervous. But I don't recall being super scared because I figured I was on this rope. I'm okay. And he starts screaming, and then all of a sudden, I saw all the people that were just sitting around waiting, all their heads kind of pop up over. So I'm looking here, and all these heads are right up top looking at me as I'm hanging upside down, and they're going to see me die, right? That's basically what I thought was going to happen. And I was like, there's no way in the world I am going to let these guys rescue me. That'd be so embarrassing. I mean, there was girls there. I didn't want to be embarrassed in front of the girls, right? And so there's no way. So I started bouncing. Up and down a little bit just to get my feet against the wall because my feet are completely straight up in the air like this. And then I was able to get myself to about right here. There's me again, hanging onto the rope. And the guy's like, no, don't move. I was like, there's no way they're going to rescue me here. And so I get like this, and then I went boing, boing, like 2 boings, and I was down the bottom. And I made it faster than anybody else did after that whole fiasco right there. So here's my story. This is what kind of slope? This is no slope. What would be left of me if I would have fallen from this distance down to these big rocks? What would have been left of me? Nothing. I would not exist. Okay? So that's what that is. It doesn't exist. What's the other thing you said when I said no slope? It's undefined. They would not be able to define me. They probably wouldn't be able to recognize me if I fell to my gruesome death on these big old rocks from who knows how high that was, 60, 70, 80 feet, something like that, okay? So I would be, that's what you laugh at? That's my incredible story, and you laugh at stupid 6'7". You got to be kidding me. You guys give me no emotion when I'm hanging upside down. You guys are bored as anything, and I say 6'7", and that's what makes you laugh. You got to be kidding me. Oh, my goodness. I hate this 6'7" thing so much. Anyway, so undefined. I would have been undefined. So I always tell that story, and every time I finish telling that story, I think, oh, that was a waste of time because they never will remember why. But this is why I want you to remember it. If you have a vertical line, okay, what kind of slope is it? Well, it's no slope, or it's what? It's an undefined slope, all right? And there's my vertical line story. All right. I don't know if anybody thought that was interesting. I know the 6'7" thing was interesting. Don't know why. It's so ridiculous, but there we go. All right. Let's come up with how to find the slope. Now, I could sit here and tell you. Now, I could probably even ask you, when you talk about slope, there is probably something that you remember from slope. Oops, I don't want that to be white. I want this to be white. Okay. What is it? Do you remember anything about slope? It's something over something. There you go. See, I knew somebody would remember. Okay, rise over run. So let's talk about that a second and talk about what that is. So let's say I had a point here and a point here. In fact, it doesn't even have to be a line segment. When we do distance always has to be a line segment because you got a beginning and you got an end, correct? So you're finding how far is it from point A to point B. That's distance. Midpoint, you're only finding the midpoint of a segment. You're not finding the midpoint of a line, right? There is no midpoint of a line. Dom, get in your regular seat. So, see, now where was I? I've told you before. So a midpoint, you have to have a segment, all right? You're finding the middle from here to here. If it was a line, there's no real middle to any line, right? Because it keeps on going forever and ever. That middle could change all the time. So A slope, though, it doesn't have to be a segment, a line segment. It could be a line segment, but it could be an entire line that keeps on going in both directions. Okay, it still has the same slant. So even if I put arrows on the ends, okay, I can find the slope of this. I cannot find the distance of that line. I can't find the midpoint of that line. Okay, but I can find the slope of that line. What they're going to do is they're going to give you 2 points. They're going to give a point right here. It could be anywhere, any 2 points on that line. I just picked those 2 particular ones. All right? And what I want to do, when we talk about rise over run, this is what we're talking about. We're talking about going from here all the way up to there, and then going across. Well, I missed it a little bit, but you get the idea. There's your other point. I'll make another point. All right, everybody see that? So that's how we decide how steep the line is. When we talk about slope, we're talking about how steep it is. Remember I talked about getting that app when I was hiking. All right, when I saw it really steep, I hated that because I had to go straight up, and that was really tough on me. When it was flatter, it was a lot easier. So the slope of the line made a difference. So here's what we do. We do call it rise over run. Oops. So the slope equals the rise over the run. All right? What does that mean? From one point to another. So I picked 2 points. All right? I want to go from this point to this point. I got to rise. So this right here is how much I rise. How do I find the slope? I divide it by how much I what? I run. Everybody see that? So that's how we can do that. Now you could go the other way as well. It'd give you the same exact number. I could go from the top point to the bottom point. I could go rise, but this time I'm rising down. You can still rise down, all right? A lot of times when we think rise, we think only going up, but going up or down is considered the rise. It's just rising in the what direction? Well, positive or negative. In the negative direction, okay? So this would be a negative. And then you could, what? Run in that direction. Everybody see that? So that could also be the rise, and this could also be the run. But this is going down, so this is like a negative rise. This is going to the left, so that would be what? A negative run. Everybody got this? Guys? Okay. So, so there you go. Now let's do that x1, y1 thing. Do you remember that? Yeah. So let's do that. So I'll call this point right here, that first point, I'll call that x1, and I'll call that y1. What am I going to call this second point right here? Good. x2, y2. All right. What would this point right here be called? You went over this direction, so how far is that? It's right above what? Look at this point. This is x1, y1, correct? So this would be going over that far. What would that be? Don't say you got to go to the bathroom.
No, it's Monday.
Oh, don't say it's Monday and you got to leave. Anything else? Okay. Yeah, go ahead, I guess. So what would this be? This would be what? x1, y2. That's right. Do you see that? That always confuses people. But if I go from here to here, how far is that? It's the same distance on the x direction to get to that point. Would you agree? So it's what? x1. How far up did I go? Well, I went the same distance as I would go up to this point. How far did I get up to this point? y2. So that's a y2. Yes? All right. So now the rise over the run. This is the change in. You remember that? The change in the rise or the y direction. So watch. I'm going to write another. This is another way to write the slope. So this would be the change in the y. Do you remember what letter? It's a Greek letter of the alphabet. It is delta. Okay. Delta y. So look, the rise is the change in the y direction. Yes? You all watching? So this is the y direction. This is the change from this point to this point. We got it? What is the change? Well, I went from y1 to what? To y2. I didn't change in the x direction at all, did I? All right, I just changed in the y direction. So I went from y1 to y2. Or you could look at it as going from y2 to y1. Doesn't matter how you subtract it. Let's go y2 minus y1. What is this direction? What is this thing right there? That's the change in x, which would be from this x, x1, to this x, x2. So how are we going to show that? We'll do it in the same direction. We'll do the same order. Okay, if I went y2 minus y1, what am I going to do here?
x2 minus
You got it, x2 minus x1. Okay? So we said the slope was the rise over the run. So the rise is the change in y over the run, which is the change in x. Or what? y2 minus y1 over x2 minus x1. That right there is what you want to remember for the slope. Do you really have to write the change or the delta y over delta x? No, but a lot of times I'll say that. I'll say the slope is the change in y over the change in x. Or I might say delta y over delta x. You got to know what that means. It just means something very simple. It just means you subtract the y's from each other. Or the delta y does. The delta x means you just subtract the x's from each other. Now notice what's on top. The y is on top. Do you see that? Because it's what? It's rise. Yeah, the y is rise. The x direction is what? Is the run. So it's y2 minus y1 over, I'll tell you what, let's write it here. Oh, I forgot one more thing. It's kind of important. They have a letter that represents the slope. Yeah, and for some reason, they use the letter M. Has a teacher ever explained to you why it's the letter M? Because nobody really knows 100% why it is, okay? I looked it up. You can just Google it, chat GPT it if you wanted to. But I Googled it, I don't know, a couple years ago because kids were asking me. I'm like, you know what? Never even thought about it. Don't know why it's an M. I just know that they gave it an M. But I found out that people aren't really 100% sure why it's an M. Some people think it's from a Latin word. I forget what it's called exactly. I'm not a Latin person. I don't know anything about Latin. I never studied it. But the Latin word that kind of meant mountain. So here's how I kind of like to look at it. Doesn't mean it's right, but why, in my mind anyway, this is how I like to think about it. I may be completely wrong, but in my mind, I think that they use the letter M from that Latin word that means mountain, and which starts with an M, all right? So I think of a slope as a what? As a mountain, because I was a hiker, right? I went up, love the mountains. It's my favorite place to go, and so we'll think of that as M for mountain. It may not be even close to correct for the reason why, but do we really care what the real reason is? Not really. Okay, yes. Oh my gosh. Are you serious? Just, can you wait 10 minutes? Wait 10 minutes. Can you do that? Just don't go on my floor. All right, let's do an example. You ready to do an example? Yes. You guess. Wrong answer. The answer is, yes, Mr. Hamrick, I would love to see an example. That's the correct answer. All right, here we go. So this is example 4, since we've done 2 other topics before this. And they give you a graph. And so they put a point right here, and they put a point right here. And what they want you to do is find the slope between those 2 points. All right. Now, this is a line. But these are just 2 points. I'll put it in red. These 2 points right here lie on that line. Where were you?
The nurse.
The nurse. Did she give you a pass?
Yeah.
Can I have it? You did. Okay, so what we want to do is we want to find the slope. Find the slope of the line. How steep is it? Okay. First of all, is it a positive slope or is it a negative slope? Just by looking at it. It's a negative slope because from left to right it's going down. Okay, so you know it's a negative slope. So if you don't get a negative answer, you know you did something wrong, okay? So what's the coordinate of this point right here, this first one? Just 2? Are you going to say just 2? 0, 2. Right, you got to put the x and the y in there. So that would be 0, 2. What's the coordinate of this point right here?
4, -1.
4, -1. 1, 2, 3, 4, and then down 1, so that would be 4, -1. So what we're trying to do is find the slope of this line. Do we have a formula for slope of a line? Let's write it down. M equals. Let's just do the y things instead of the delta. All right, so what is the slope? Y what? y2 minus y1 over x2 minus x1. Now, what's really important here, if you wanted to, you could write it y1 minus y2. But what would you have to do if you go y1 minus y2? No. If you do that to the y's, you got to do it to the x's, okay? So they got to go in the same order. You got it? Now remember, the y's have to be on top. Don't put the y's on the bottom. A lot of people think, oh, x is first, so x goes on top. No, no. It's not run over rise. What is it? It's rise over run. So the y has to be on the top. Everybody hear that? All right. So you could go y2 minus y1, or you could go y1 minus y2. But if you go y1 minus y2, you're going to have to go x1 minus x2. Everybody got that? Okay. So here's my 2 points. Sometimes it's a little easier if I just write the points next to each other. Like this. Okay? So this is my first point. So that's my x what? 1 and my y1. And this is my x2 and this is my y2. So if you do that, especially at first, okay, when you're first starting to do these things, it might make it a little easier for you. So now let's find the slope. This is super easy. I took all that time just to do this problem, and this problem is just so quick and so easy. It really is, okay? But I'd like you to know the background, you know, all the stuff that goes before it. And that's why I take all the time with it. All right, so y2 minus y1. So here's my y2, which is what? What's the y2 here? -1. Okay, and then I do what to it? Minus the y1. So I basically just subtract the y's from each other, okay? But if you subtract the y's from each other in a certain order, you got to subtract the x's from each other in the same order. So if I go y2 minus y1, I absolutely have to do what? Start with 4, right? 4 minus what? 0. That's really all there is to it. You subtract the y's, stick it on top, subtract the x's, stick it on the bottom. Just make sure you subtract the y's in the same order as that you subtract the x's. Everybody got that? Hear what I said? A lot of people did not. Okay, Dom, what's the fascination with that chair? Push it in. Okay, thank you. It's distracting to me. All right, so I subtract the y's. Remember what I said? Another way you could do it? You could go y1 minus y2, couldn't you? Let's see if that really is true. Let's see if I get the same number. I haven't even got an answer yet here, did I? But let's do it the other way. Let's go, you don't have to do this 2 ways. I'm just showing you that it will work either way you do it. So I could do what? y1 minus y2. Let's do that. So that's going to be 2 minus what? Is it just 2 minus 1? It's 2 minus -1. That's super important that you realize that this is subtraction, but sometimes you subtract a negative, and you got to put that negative there if it is a negative, and it is. All right, let's do the x's. Let's do the first x minus the second x. 0 minus 4. Again, you don't have to do it both ways. I'm just showing you that both ways work. Let's see what we get on the first way. -1 minus 2 is -3 over 4 minus 0 is 4. Let's see if that is the same as this. What's 2 minus -1? +3. And then what's 0 minus 4? Is it 4? It's -4. Is -3 over 4 the same thing as 3 over -4? Yes. Absolutely, it is. They are exactly the same number. What's another way I could write a -3 over 4? I could put the negative right in the middle, couldn't I? And then call it 3 over 4. Both of these answers are perfectly, or all 3 of these answers are perfectly fine, okay? You could use any of those answers. So that, and that are the same exact thing. Make sense? And that's what the slope is. All right? That means for every 3 up you go to the what? Left. Every 3 up you go 4 to the left. Or every 3 you go to the left, which way is your left? This way. Okay. Every 3 you go to the left, you go what? I'm sorry. Every 3 you go down, that's the rise. Every 3 you go down, you go 4 to the right. Okay? That's what you're doing. And it is a negative slope, just like we said it would be, didn't we? We said it was going to be negative just by looking at it. My numbers came out to be negative, so you should be good. Now, sometimes they'll give you a graph, and you got to do that. This way is actually a little easier. That was part A. This is part B. So sometimes they're just going to say find the slope through these 2 points. And they'll just give you the points. To tell you the truth, this is, I think, easier than when they give you the graph. All right? I'll give you 20 seconds to do this. Ready, set, go. Finding the slope. Oh, find through. Find the what? Find the slope that goes through. Here, I'll add a couple more seconds to you. Everybody do it. You should write it down. You're taking notes, right? You should be taking notes. Write down that. So it's 1, -4, and 3, 2. Find the slope. You should be able to do it really quick. Okay, just hang on. I'll start you off. I'll put m equals. And I'll even give you the formula. Anybody get an answer yet? Okay. What'd you get? 3. Anybody else? Tom? -3. Anybody else? EJ? -2 over 2, which is what? -1, right? Okay. Yep. You got 3. Anybody else want to volunteer? That's it? All the brave souls? Everybody else is a math coward? All right, here we go. Let's see what we get. It is one of those. All right, which one do you think it is?
3.
Why? Just because Cameron said it? What? You don't believe anybody else? All right. What'd you say? Glaze? What were you saying?
Yeah.
Is that what is that if like if you bust on somebody or something like that?
Yeah,
Or
like I'm like building him up.
oh, building them up? Is that what that means?
Giving him like false. It's praising him. Like,
Okay. All right. Glaze. I haven't heard that before. All right. Nah, I don't. I hate LeBron, so I'm not glazing LeBron. I'll tell you that much. Is that how you say that, or is that how you would say it?
if someone was like missing
Okay.
their vest, it could be like you're glazing.
Oh well, you can glaze me. That's all right because I deserve it. All right, here we go. We took way more than 20 seconds for this, didn't we? Here we go. Y2 minus Y1. So let's watch. So I'm going to go 2 minus what? -4, right? Here's the Y. Here's the Y. It doesn't matter what order you subtract them, but I'm going to do it this way. The second Y minus the first Y. Then let's do the X's. Again, the second X minus the first X. So that's 3 minus 1. 2 minus -4, that's plus plus, so that's a 6 over 3 minus 2, which is +2, and there you go. It's +3. So +3 is the answer. Make sure you understood. Make sure you understand why it is. All right, well, that's all I got for now. Tomorrow we're going to do a little bit more, some more homework, and they're going to be a little bit harder than these. These are super basic. These last 3 homeworks are just, they give you the points and you just find the distance. They give you the points, you find the midpoint. They give you the points and you find the slope. In the second part of this, not today. Today's going to be just as easy as this. It's just going to be like 9 problems just like this. Okay? So, or 10 problems. Let's see. Here we go. Section 3.4C. Shh, guys, please. Look, we can have some give and take in here. I don't mind that. But sometimes you guys just take it way too far, okay? When it's over, it's over, okay? You can laugh about it later, talk about it later. But I want you focused on what we're doing right here. All right, so there's your third section. You've got like 20 minutes, 22 minutes. You should be able to finish this way before class is over. So let's get that done. Let's not have any homework tonight. All right, let's get it finished in here. And check your odd answers. Once you do an odd problem, go back, look at it, make sure you're getting it right before you go to the next one. Okay? Have you been doing that? All right, you should do that in every math class. All right, if the odds are in the back, you do a problem first, you look in the back, see if you got it right. If you got it right, go to the next one, right here.
Last year, Mr. Cheadle, he would only give us the evens so we couldn't look at the odds.
Yeah. See, I'm fine with the odds if you use them correctly, all right? I'm fine with using AI sometimes, right, on doing math if you use it correctly. If all you do is just use AI to find the answer and write it down, you're not using it correctly, okay? You're not benefiting yourself. Same thing with the odds, okay? So I like to have the odds in there because it makes me know if I'm doing them right, you know? And you don't want to do 10 problems wrong and then find out when you come to class the next day. Wouldn't you agree? Yeah. Okay.